So we've got a 2017 2500 HD Chevrolet with a L5P Duramax. It came in, complaint was reduced power, check engine light. So got it in here, plugged her in, scanned the codes. We got a couple of temp codes for the temp sensors on the exhaust system, and then one open circuit for sensor number 5, which is aft of the DPF. So the first thing I did was I'll look at freeze frame on the P200 Charlie, which is the DPF temperature over temp, and it was showing a temperature of like 1850 degrees if I remember right. So saved it in my scan tool, but anyway, that's completely implausible. And the P200E is the catalyst over temp. I'm gonna just kind of ignore that because that's a result of this DPF over temp. And we also have a P2482, which is an open circuit on sensor 5, which is the sensor that's aft of the DPF, and it's measuring the exhaust temperatures coming out of the DPF. And this is the one that also set the over temp code. So record all that, clear the codes, started a regen on it, and monitored my temperatures, and everything was fine on temp sensor 5. It got up to like 1100 degrees, 1050, right around in there, pretty stable. And then all of a sudden I saw it actually jumping up to 1800, over 1800 degrees all by itself, while monitoring the others, and they were staying in the range that I am, would expect to see when you're doing a regen. So there wasn't any problem going on up ahead of that. So it's pretty simple. There's likely something wrong with this sensor. Could probably overcomplicate things and check the wiring harness and throw a scope on it. I'm not sure what that would tell you, scoping it, but definitely checking the circuits on it. So the way this thing works is it's on one of the 5-volt references. It gets a 5-volt signal that's sent to it, and then it has a return, and 5-volt comes from the ECM, and the return also goes back to the ECM. And then this is a variable resistor or thermistor, and as the resistance changes on this, as it heats up, the power is sent back, that signal is sent back to the ECM, and it does its magical mystery miraculous calculations and determines what the temperature is. So an open circuit on one of these, they will go to 1800 degrees. So I'm going to assume that these are like $50. So for $50, I'm not gonna, that's the first thing I'm gonna do. And this is, I'm 99% sure that this is gonna fix it. But if it doesn't, it's only $50. Then I can do my other tests, that I need to do on my circuit, on my, pin tension and all of that stuff, and condemn the PCM. When you look at the service information, you have over temp codes. If I didn't have the open circuit on here, I probably would get a little bit more detailed in my diagnosis, but since I have the open circuit on there, I have an open circuit somewhere, and most likely it's in the sensor. It's just going, the resistance is just going so high when it gets up to a certain temperature that it's, basically open. So, and the PCM's just going, okay, whatever. The P200E, which is the catalyst temp, that's probably a default, just to kick things into reduce power mode and shut the engine down if necessary, so you don't have some big ugly thermal event underneath your truck. So we're not going to go down any of that road. We're going to take the easy route and do this, although it would be fun to do all that testing and stuff. But at this point, there's no need to, because $50 is pretty easy to change that. So these systems, the SCR system on this is a 17, it's quite a bit different than the systems. Well, not quite a bit, but there's some differences in there than there are in the very early systems that came out when the system first came out. Here we've got a catalyst right behind the turbo, and it's the pre-catalyst they call it, and then you have your main catalyst underneath there, and they have some fancy name for it, and I can't remember what it is, because we keep changing names and naming things new names, and if I saw these every single day I might remember them, but and then we've got 5 exhaust temp sensors that are monitoring those temps in between the cat and after the cat, before the cat up here, the pre-cat, and then we got number 3 down there, number 4, and then number 5, which is the aft sensor. We've got a pressure differential sensor on there. We've got our reductant injector that's before the main cat under there, so the diesel exhaust fluid is actually being injected right into the cat, or just a little bit upstream from the cat, and of course that reduces your NOx. We've got a couple of NOx sensors, and then we also aft of the DPF filter, or the particulate filter, there is actually a particulate matter sensor, which is a sensor that has some combs on it, and as the particulate builds up on there, it changes the resistance on it, and magical calculations take place in the ECM, and determines how much particulate is in there, and then it can decide if it can actually figure out if that filter is bad or not, if it's doing a good job of trapping the particulate matter. And I mean, that's basically how they all kind of work the same. GM does it a little bit differently than Ford does. Ford has one big unit that's easy to steal, so Sawzall, cut some wires, take the whole thing. On this, it's sectioned off, so you can actually replace components on this one separately. You got your pre-cat, you got your cat down there that'll unbolt, and then you have your DPF, which the tailpipe is actually part of that. But you can replace the component that's bad without having to cut it open. But these don't go bad very often. Things that they want you to check when you have over temp codes, if it was actually overheating, what's going to cause it to overheat. Well, you could have if you had an overfueling, or if you had a a charge air cooler system leak, if your injectors were leaking, things like that. You could check all that, check your balancing rate and all that, give the CAC system a quick look-see. But based on what I'm seeing here and then my open circuit code, and this thing runs really good, I didn't look at any of that because there's really no need to. But we would have other codes, because this thing is, I mean, there are sensors all over these engines, and fuel pressure sensors, and we've got NOx sensors on the exhaust. And if there was any kind of a condition going on like that, the ECM is monitoring that, so you're going to have some other codes if you have that stuff going on. So it's kind of a waste of time to do that. And these sensors are really cheap, and they're pretty easy to change, except getting the connector apart can be kind of a challenge, because it's hard to get at on this one. But anyway, we're going to replace this and do a partial regen on it. It doesn't need one, but just so we can see our temperatures stabilize and make sure they're staying within range, where they should be, and not overheating. So, which I'm certain they're not going to after this. So anyway, another Duramax, easy fix. These things are always easy to fix. If it had a oval on here, a blue oval, we'd probably be jacking the radiator cap up and replacing everything underneath of it. But it's a Chevy, so after 6 or 7 years, we have one little component go bad on it. Not bad. So anyway, thanks.